Hello and welcome to Southern Illinois University, Department of Mining and Mineral Resources Engineering. Nowadays, the burning of coal generates about 40% of the electricity in the United States. Byproducts of coal combustion are starting to accumulate. Most of the coal combustion byproducts are rich in valuable minerals that can be sustainability point of view. Today we are introducing to you the research and work of experiments done by an EPA study. The study is focused on the recycling of one of the coal combustion byproducts. Every year, about 130 million tons of waste are generated by the burning of coal. These major products are bottom ash and fly ash. The concentration of this study is to find or reuse fly ash in the construction and metallurgy industry. As shown in the flow sheet, coal fly ash disregarded from power plants contains different types of valuable minerals. If the fly ash is rich in valuable metals, a series of mineral separation applications can be applied to recover them in the form of metal oxides. In our study, about 95% pure magnetite can be recovered from fly ash using a magnetic separator. The non-magnetic fly ash contains a high percentage of aluminum, titanium, and other metals that can be leached out using acid solutions. On the other hand, if the fly ash contains poor minerals, it can be used to generate cementless concretes through geopolymerization processes. Today, cement production process accounts for 6 to 8% of our national CO2 emissions, which is a major greenhouse gas. One major purpose of fly ash reuse is to make geopolymer concrete instead of ordinary Portland cement concrete. This is a sample of our geopolymer concrete. In our study, the results were showing that the compressive strength of fly ash-based concrete is comparable with Portland cement-based concrete. The regular cement concrete used for construction purposes has to reach 4,000 psi. This is a sample of our regular concrete, Portland-based cement concrete. However, the optimal strength that we had from the geopolymer concrete cylinder was reaching 7,000 psi after 1.5 years old. In the next frame, we're going to show you the process of making geopolymer concrete and the associated tests with it. For example, 1,000 grams of 12 molar sodium hydroxide solution requires 360 grams of 98% sodium hydroxide flakes and 640 grams of distilled water. Slowly adding the flakes into the distilled water and mixing the solution well until everything is dissolved. The sodium hydroxide is corrosive and heat released. All lab protection must be used while making this solution. The sodium silicate solution we need has a mass ratio of about 30% sodium oxide, about 15% silicon dioxide, and about 55% water. With the sodium silicate powder, we purchased 1,000 grams of such sodium silicate solution. It requires about 540 grams of powder and about 460 grams of distilled water. Slowly add the powder into the water. Make sure the powder is not getting lumped. The sodium silicate solution is supposed to look like a gel. At last, mix the sodium hydroxide solution and the sodium silicate solution with a ratio of 1 to 2 to obtain the alkaline solution. In our experiments, a total of 1,950 grams of mixed solution is needed to produce about 9 cylindrical geopolymer concrete samples. The solution needs to be placed in a room temperature environment for 24 hours to complete the reaction. We use this mixer to make our geopolymer concrete samples. In total, roughly 40 kilograms of material will be added to the tank step by step. Material contains coal fly ash, the coarse aggregate, sand, and the solution we had prepared in a video earlier, as well as some water. The design of the mixture was modified from general cement concrete mixture by replacing cement as coal fly ash and water as an alkali solution. The geopolymer concrete process not only reduces CO2 footprint in the cement producing, but also by saving half the amount of water used cement hydration process. First comes the dry materials. They consist of 18.5 kilograms of coarse aggregate, 13.9 kilograms of fine aggregate, and 5.6 kilograms of fly ash. A little bit of hand mixing helps. After dry mixing for 3 minutes, the ready-made alkaline solution is slowly added into the dry materials while mixing. And then a small amount of water is added into the mixed materials to make it a paste. The amount of water that is needed depends on the workability of the paste. It can be tested by slump tests, which displays the viscosity of the material. The process of adding the solution of water should be within 2 minutes, and then mix for another 2 to 3 minutes. The paste mixing is done. The slump test is used to determine the amount of extra water added during concrete mixing. The workable paste with minimum amount of extra water is in the best condition. To do the slump test, a 12-inch high cone mold is used. After the paste mixing is done, fill up the cone in 3 times with tapping on the top for 25 times each and tapping on the side for 8 times. Right after filling the cone, lift the mold up and measure the height drop of the paste. In general, 4-inch height drop provides the best workability and the minimum water.
To cast the cylindrical concrete samples, first we need to grease the cylindrical molds with lubricant. For each cylinder, 3 scoops should fit in. After loading in each scoop, the paste needs to be tapped 25 times on top and 8 times on the side using a steel rod. After filling up the molds, the vibration table is commonly used to help cast a smooth, flat surface on the top. 10 seconds of maximum vibrating time is recommended. In general, the cast concrete samples need to be left in room temperature for 1 day to let the material rest for a better reaction. After 1 day, demold the concrete samples using high pressure air.
Now that the cylindrical concrete samples have been rested for 7 days after curing, the compressive strength of the concrete can be tested for the first round. We monitor the strength variation in the early stage of the geopolymer concrete at day 7, day 28, and day 60. This is the machine that we do all of the concrete sample testing in. If long-term monitoring is needed, the sample can be stored for 1 to 2 years. In each test, 3 samples are compressed for a better representative strength.
Place the cylindrical sample in the middle of the compressor. Start the compressor and carefully track the strength on the gauge meter. When the sample failed in compression, the peak strength that the concrete can be held is recorded on the meter, which is the ultimate compressive strength. Freeze-thaw tests can be applied to evaluate the performance of geopolymer concrete using specific freeze-thaw machine, with warm and cold environments alternatively. The geopolymer concrete sample that is needed to be made to run freeze-thaw tests are following the same mixture and making as the paste in a mixture. The mold used for freeze-thaw testing concrete samples are rectangular solids. After the paste has been made, fill the mold in 2 layers, and for each layer, tap on the material to make sure the containers are filled. After curing in the oven, the samples are rested at room temperature for 14 days, then placed in the freeze-thaw machine. Tracking the weight of each sample to measure the lost material for geopolymer concrete performance in cold weather. A wet magnetic drum separator, manufactured by Seaport Inc., has been used to recover magnetite from the coal fly ash. It utilizes a permanent magnet of low field strength to recover highly magnetic fine particles. The rotating stainless steel drum, which contains stationary ceramic magnets, is partially immersed in the feed slurry. The drum is rotating countercurrent to the feed slurry flow direction to recover prime grade of magnetite. The magnetite particles attach onto the drum shell and are carried over to the product launder. at where the magnetic particles detach. Non-magnetic particles continue to stay in suspension and report to the tailings discharge. A spray water stream is applied at the concentrate discharge to remove entrailed non-magnetic particles, thus to improve the magnetic product quality.
The purity of magnetite from fly ash can be tested using Davis tube device. The Davis magnetic tube tester consists of an extremely powerful electromagnet, which can generate a magnetic field. Mix fly ash powder with water and pass through the glass tube. The magnet will catch up the magnetite particles, while fly ash will be washed off. Turn off the magnetic generator and collect the magnetite particles.
Here we are in the SIU Hydrometallurgy Lab, where we are going to show fly ash leaching experiments. The lab reactor for fly ash leaching automatically controls the temperature of the solution and the stirring speed of the blades in the vessel. In the next, we are going to use sulfuric acid solution to leach aluminum from fly ash. In this experiment, we are going to dilute 98% concentrated sulfuric acid liquid with distilled water to obtain sulfuric acid with a concentration of 6 molar. This will be used as the leaching solution. To obtain the 1,000 milliliters of 6 molar sulfuric acid, 325 milliliters of 98% sulfuric acid, and 675 milliliters of distilled water are required. Pour 300 milliliters of distilled water in the flask. Slowly pour the concentrated acid to the flask through a glass tube. Then spray the water to wash off the acid on the inner wall of the flask, slowly adding water till the solution reaches 1,000 milliliters. Carefully add the prepared 6 molar sulfuric acid into the vessel, and then add the fly ash sample into the sulfuric acid with a solid to liquid ratio of 1:4. The lid must be locked during the reaction. Slowly increase the speed of the stir to 120 RPMs, to which it's to be set at. After observing the solid to liquid mixture is well mixed, set the temperature at 100 degrees Celsius. Operate this experiment for 10 hours. After 10 hours, the leachate is separated from the residual fly ash by filtration. The leaching cake is washed using distilled water to remove remaining leachate solution in the residual fly ash. Then mix the diluted leachate solution with the main leachate solution. Dry the fly ash cake in the oven and seal properly in a sample bag. Both the leaching solution and dried residual fly ash will be sending for component analysis to calculate the aluminum extraction.